Welcome to the Architecture Corner.
Hi there.
Today we're tackling a pretty common point of contention, I think, among developers, software abstractions.
Ah, yes. Abstractions. Definitely a topic that stirs up, well, strong opinions. For some, it feels like unnecessary complexity, maybe even academic overhead that just slows things down.
Totally. You hear that a lot, right? Like premature abstraction is the root of all evil, or, just this feeling that we're adding layers and interfaces just
Like that.
without a really solid reason.
And that pushback isn't always wrong. Our source for today, an article called Abstractions Done Right, actually acknowledges those criticisms head on. It tries to get past the common misconceptions
Like,
and argues for what the real power of things like interfaces and layers actually is
yeah.
when, they're done well.
And it's interesting, the article even mentions how applying DRY, don't repeat yourself too early, maybe without fully grasping the problem, can sometimes lead you down the wrong path towards, well, bad abstractions.
Exactly. It sets the stage nicely by challenging some of the standard justifications we hear and offering a more, let's say, nuanced view.
And it uses practical examples, right? I saw there's some code snippets linked.
Yeah, TypeScript examples, they're definitely worth checking out. We'll put the link in the description. Seeing the code helps make these ideas more concrete.
Cool. So our mission today, figure out why abstractions can be so valuable, maybe for reasons we haven't really thought about, and how to use them effectively without, overdoing it.
Sounds good. Let's dive in. The article first looks at interfaces, especially in OOP.
Right, interfaces. So they're basically contracts,
Mhm.
defining what something does, method names, inputs, outputs, but not how it does it internally, like the entry repository interface.ts example in the source, defining how we save or retrieve data.
Precisely. Now, the first big argument you always hear for interfaces is future-proofing, the idea that you can easily swap out implementations later.
Yeah, the classic, let's put an interface in front of Postgres so we can switch to DynamoDB later example.
And the author is, well, pretty blunt here, they actually agree with the critics on this point. They say, look, in practice, swapping out a whole persistence layer in a live system, it's really, really rare.
Okay, yeah, I can see that. It sounds like a massive undertaking.
It is, and the article points out, even if you did do it, the actual effort saved by having that interface, it's often tiny compared to everything else, migrating the data, dealing with different feature sets, running both systems in parallel for a while.
Right, the interface is like the least of your worries at that point.
Exactly. So that specific justification, while maybe technically true, doesn't hold a lot of practical weight as the primary reason.
Okay, so if easy tech swapping isn't the main event, what's the second common argument the source tackles? Testing.
Yeah, testing and dependency injection. The idea that interfaces make it easy to swap in mocks or fakes for your tests. Use a test mock interface.ps instead of the real database code.
Makes sense. But the article pushes back a bit here too, doesn't it?
It does. It points out that in a lot of modern languages, think Python, JavaScript, even TypeScript, you can often achieve that same easy mocking without a formal interface. You can mock the concrete class directly or use duck typing. The test mock repository.ts example shows this kind of alternative.
Ah, okay. So if those two big selling points, future swaps and easier mocking, aren't the whole story, or are maybe less crucial than we thought?
Then the critics will be right. If those were the only reasons, maybe you don't always need that interface. But the article argues they aren't the main reasons.
Okay, this is where it gets interesting then. What is the main reason? The superpower, as the source calls it.
The real value, the superpower, is something different. It's about enabling you to defer decisions.
Defer decisions, you mean like putting off choosing the specific technology?
Exactly. It lets you define the intent, what you need something to do using the interface, even if you haven't nailed down how it's going to do it yet. You establish the contract first.
Got it. So I need a way to store this data. Here's the save method it must have, but I don't need to decide right now if that's going to be a database, a file, or something else entirely.
Precisely. And this ties really well into iterative development, vertical slices, ways of building software incrementally. Interfaces become a tool to isolate parts of the system and keep moving, even with some unknowns.
Like that in-memory entry repository.ts example. If I'm building a feature and the database isn't ready, or we haven't decided which one, I define the entry repository interface.ts, whip up a quick in-memory version.
And you can keep building the rest of the feature that uses that repository. You're unblocked. The core logic can be developed and tested against the interface in the simple in-memory implementation.
And you push the final database decision down the road.
Right. And the benefit is when you do make that decision, you probably understand the requirements better. You've maybe learned more about the access patterns, the constraints, so the final choice is more informed.
Less guesswork.
Less guesswork, less chance programming, as the article puts it. You're building confidence as you go. The investment in the interface is small, defining the contract is usually straightforward, and it gives you that breathing room.
So that diagram in the source showing the client code talking to the interface, which could be backed by DynamoDB or Valkey or Postgres. The flexibility is still there, but it's more like a beneficial side effect.
Kind of, yeah. The primary win was the ability to defer the choice and define the intent clearly up front, making the development process smoother and the final decision better. The swappability is a bonus.
Okay, that makes a lot more sense. It reframes the value proposition significantly. It's about managing development complexity now.
Exactly.
All right, so that's interfaces. What about the other big abstraction the article tackles? Layers. Like in MVC, clean architecture, ports and adapters.
Layers. Another source of spirited discussion, especially with microservices, right? People say it's a microservice. Why do I need all these layers? Just keep it simple.
Yeah, it feels like that overhead argument again. Adding extra files, extra classes.
It's the same underlying tension, but the article argues the principle is the same as interfaces. Responsibility segregation. Each layer has a specific job, a specific focus.
And the source links this to cognitive load, right? Which I think is a really helpful way to think about it.
Definitely. Cognitive load is basically how much stuff you have to keep in your head at once when you're working on code. Layers help manage that by breaking the problem down.
So instead of one giant function doing everything.
Right. Imagine trying to debug something that handles the incoming HTTP request, parses JSON, validates inputs, runs complex business logic, talks to 3 different database tables, calls an external API, and then formats the response. All mixed together. Your brain explodes.
Been there.
We all have. Layers create boundaries. You can focus on the UI layer concerns without worrying about the database details, or focus on the business logic in the application layer without getting bogged down in HTTP specifics.
The article mentions a specific 4-layer approach: UI, application, domain, infrastructure. Can we quickly run through those?
Sure. So starting from the outside, UI layer, this is the entry point, handles the request API call, message queue event, maybe a CLI command. Its job is basically parsing the input, maybe some basic validation, creating a command or DTO.
DTO, data transfer object.
Yeah, just a simple object to pass data between layers, and then the UI layer formats the output. The create entry UI.ts example, like an express handler, fits here. It abstracts how the system was triggered.
Okay, then application.
Application layer. This orchestrates the work for a specific use case. It takes the DTO from the UI layer, uses domain objects, calls infrastructure components, usually via interfaces defined in the domain, and coordinates the whole flow. It doesn't know anything about HTTP or message queues. The create entry handler.ts is the example here.
Got it. Next, domain.
Domain layer. This is the heart. Your core business concepts, entities, value objects, the really critical business rules. It often defines interfaces for things it needs, like I need a way to save an entry, but doesn't implement them.
And finally, infrastructure.
Infrastructure layer. This provides the concrete implementations for those interfaces defined in the domain. So your actual database query code, your HTTP client code to talk to other services, message published code, it all lives here.
Okay, so UI, how it comes in, goes out, application, the specific steps, domain, the core rules, infrastructure, talking to the outside world.
That's a good summary. And again, this separation helps with testing. You can test your application layer handlers, create entry handler test.ts, by mocking the infrastructure stuff without needing a real database or web server running.
And the article notes that this doesn't have to mean tons of extra code, especially with modern tools, maybe even AI assistants, helping generate some boilerplate.
Right. It's structure, not just size. The goal is clarity and reduced cognitive load.
Okay, theory's good, but the article also has stories, right? Real-world examples.
It does, which really helps ground these ideas. The first one is about migrating a service.
Oh, yeah.
Yeah, it was initially built on AWS Lambda, triggered by API Gateway, standard serverless setup. But later, they needed to move it to run in containers on Kubernetes, or K8s.
Okay, so a lift and shift from serverless to container orchestration. That sounds potentially painful.
It could be. But the key was the original Lambda service had been built using that 4-layer architecture. The actual Lambda handler code was isolated in the UI layer.
So when they moved to K8s.
They only really needed to change the UI layer. They wrote a new entry point compatible with K8s, like a standard web server handler, and updated their deployment pipeline.
But the rest, the application logic, the domain rules, the infrastructure code talking to the database.
It was the exact same code. Didn't need to touch it. The first diagram in the source shows this really clearly new UI layer plugging into the existing stack.
Wow. Okay, that sounds like a huge win. That layering directly saved a ton of rewrite effort.
Absolutely. Made the migration way smoother. They could even run both versions side by side for a while. Testing the core logic was easy because it hadn't changed. A big payoff for that initial layering decision.
Impressive. What's the second story? A counterpoint.
Sort of, yeah. It's about using AWS step functions for workflow orchestration. Each step in the workflow was a separate Lambda function.
Okay, common pattern.
Right. And following their standard practice, each of those individual Lambda functions implemented the full 4-layer pattern internally.
Even if the step was doing something really small.
Exactly. Even for simple tasks, maybe just transforming some data or making a single API called daylam, the Lambda had the UI handler, an application command handler, domain objects maybe, and potentially infrastructure code. The diagrams show this setup.
And how did that turn out?
The feedback, according to the source, was that for those very simple small steps, the full layering felt like, well, overkill. Too much ceremony.
Like adding commands, handlers, DTOs, just added boilerplate without much real benefit for a tiny task.
Precisely. It actually increased the cognitive load slightly for those simple cases because you had to jump between more files for something trivial.
Interesting. So the abstraction, applied too rigidly maybe, wasn't helping there.
Yeah. It led them to rethink and adopt a more flexible approach. The lesson was, for simple atomic tasks within that kind of workflow, maybe you consolidate. Maybe you skip the infrastructure layer if there are no external calls. You still keep the core domain logic separate if it exists, but you don't need the full structure everywhere, always. The simplified diagram shows this leaner approach for simple steps.
That's a great reality check. It's not about dogma. It's about applying the pattern where it solves the problem, which is usually managing complexity. If the task itself isn't complex, maybe the full pattern isn't needed.
Exactly right. Find the balance. Be pragmatic, but intentional.
Okay, so we've talked interfaces, layers, the real reasons they're valuable, seen stories where they paid off big and where maybe they were too much. Bringing it back to the listener, why should you care about all this nuance?
Well, because these choices directly impact the code you write and maintain every single day. How easy is it to understand? How easy is it to change safely? How quickly can you actually deliver value? Abstractions are fundamental to those questions.
So quick recap. Abstractions like interfaces and layers aren't just overhead. Their main power, according to Abstractions done right, is letting you defer decisions and manage cognitive load through separation of concerns.
Right. Ease of replacement, easier testing. Those are often nice side benefits, but not the core drivers. The goal is clearer, more manageable, more maintainable code now.
And the stories show it's okay to adapt. Don't be afraid to adjust the level of abstraction based on the actual complexity you're facing, like in that step functions example. Just be clear why you're making that choice.
Consistency and clarity in your reasoning are key.
Okay, before we wrap up, time for that provocative thought.
All right, so if the main value is deferring decisions and achieving clarity, when is the optimal moment to actually introduce an abstraction like an interface? Is it the second you think you might need variation in the future? Or should you wait until you have the first concrete example of that variation, the first real use case that forces the separation? Where's that sweet spot? Something to think about in your next project.
Ooh, good one. Resisting premature abstraction versus planning for inevitable change.
Yeah.
That's a constant balancing act.
It really is.
Well, that was a fascinating deep dive. Really appreciate you walking us through the source and clarifying why abstractions, done thoughtfully, are so important.
My pleasure. The key takeaway is using them strategically. Not just because a pattern exists, but because it genuinely helps manage the complexity you're facing.
Makes total sense. And hey, don't forget to check out the description. We've got the link to the original Abstractions Done Right article and those TypeScript code examples we mentioned. And if you enjoyed this discussion and want more like it, definitely subscribe for free to the Architecture Corner newsletter. We share insights like these regularly. Thanks again for joining us for this deep dive in the Architecture Corner.